Shh. The last lesson we looked at what ratios are. What we said was that ratios are just like fractions. Whatever we do with fractions, we can do with ratios. Well, some of those that we can do with fractions, we can do with ratios, okay? And one of them would be simplifying them. So let's have a look at our warm-up activity here. Write the ratio of faces to blocks in 3 different ways. 3 to 4. So that's one. It said in 3 different ways. Can we say 4 to 3? Are they the same? 3 to 4, 4 to 3? Thought we said something very important yesterday about ratios, about the terms in the ratio. Who can remember? So is it 3 to 4 or 4 to 3? Remember, it's faces to blocks, right? So can we say actually 4 to 3? Yes or no? No. Why? Face needs to be first and the order matters, right? So we can't just swap them around, or else what will happen with our creme caramel, right? It will not have the right consistency. So we can't just swap them around, right? So it has to be 3 to 4, but it does say in 3 different ways. Why are there, can there be 3 different ways? 6 to 8, yay. And what, 3 per 4 in 3 different ways? Maybe as a fraction, 3 to 4. So those might be your 3 different ways of writing 3 to 4. So in ratio form, right? In fraction form, and also in written form, okay? 6 to 8 would be another way of renaming that fraction, right? But that would still be in the ratio form, right? Write the ratio of blocks to the total in 3 different ways. 4 to 7, and similarly we can write it down as 4 on 7, or as a fraction, or in written form you say 4 to 7. Okay, what does the ratio 3 to 7 represent from the above diagram? Right, so that would be the ratio of faces to the total. Well done. I don't think you need me here anymore. Okay, so that's all spot on. All right, next. So we said we can simplify fractions, and therefore we can simplify ratios. Express the ratio 16 to 24 in simplest form. So the first thing we do, we write out the ratio, right? So you write 16 to 24. Now, the second step would be for you to determine the largest number by which both 16 and 24 can be divided. What do we call that? We call that the highest common factor, right? So 16 to 24 is simplified to 2 to 3, right? Does that make sense? Yeah, just like maybe if we would imagine that that's a fraction, 16 to 24, you could say that 16 on 24. Now, how do you simplify this fraction? Again, you divide the numerator and the denominator by the same number. It's the highest common factor, right? So the highest common factor of 16 and 24 is 8. You divide 16 by 8, you get 2. You divide 24 by 8, you get 3. And therefore, 16 over 24 is 2/3. Okay, let's have a look at this example here. What's different from the previous question or the previous example to this example? There is a decimal. That's one difference. Thank you. What else? They are in centimeters and the other one's in meters. Well, one, yes, Sean, that it should be whole number, and that's very important when we would be simplifying these examples later. And then the other one is that you need to make sure that they've got the same unit. You need to convert them into the same units, because ratios don't use units, right? So when you have 45 centimeters to 1.5 meters, what would that be in simplest form? So the first thing we need to make sure they've got the same unit. So we're comparing them in the same unit, right? So we've got 45 centimeters to 1.5 meters. We know that in a meter, there's how many centimeters? 100 centimeters in a meter, and therefore want to convert 1.5 to centimeters, we need to multiply 1.5 by 100. And how do we multiply it by 100? We can use our good old calculator, or how do we multiply with hundreds or powers of 10? That's 2 zeros there. You would need to move your decimal point 2 units to the right, and therefore that becomes 150. Therefore 1.5 meters is 150 centimeters. Okay, so now we've got 45 centimeters and 150 centimeters. We can now take out those units because ratios don't use units. We can write out our new ratio, 45 to 150. And now think of our highest common factor. What is the highest common factor of 45 and 150? It's 15. And how many 15s go into 45? There's 3. And 150, how many 15s go into 150? There's 10 of them. And thanks, Sean. And therefore you get 3 to 10. All right, so the ratio of 45 centimeters to 1.5 meters in simplest form is 3 to 10. You don't just say it's 45 to 1.5, right? Because that wouldn't be correct, because you're not comparing those two quantities and when they don't have the same units. Okay, so look at this example here. What's different here? They're fractions. Who likes fractions? Yay, no one's putting their hand up. Okay, so fractions, our good old friend fraction. All right, so we've got 2/5 is to 7/10. So we want to simplify ratios, and Daniel pointed out a really good statement a while ago. He said it should be a whole number. And what do we know about fractions? Are they whole numbers? No, no way. Fractions aren't whole numbers, all right? So we need to put them into whole numbers. So let's probably not look at this yet, because I want you to maybe try out a different strategy. Maybe this strategy would work with the second one, but the first strategy can actually be simplified in a better way, or in a more efficient way. How? 2/5. 2/5 would be a common fraction, right? We can convert 2/5 into a decimal. Decimals would be less challenging, all right? So decimals would be friendlier than fractions. So sometimes it would be useful if you convert fractions to decimals, right? So 2/5 would be what in decimals? A fifth is 0.2, and therefore 2/5 would be equal to 2 times 0.2, or 0.4. Thanks, Seth. So 2/5, we know it's equal to 0.4. Now, how about 7/10? 7/10 in decimal would be 0.7. Yes, Raiden and Imam. So 0.7, right? So now we can rewrite 2/5, the first term as 0.4 and the second term as 0.7. Now, Daniel said a while ago, they need to be whole numbers. These decimals are not whole numbers. If we multiply 0.4 by 10, we get 4, and multiply the other term by 10, which is 7. And therefore, we get 4/7, which is actually what they got there. But they've got a more, confusing way to do that, because they had to rename 2/5. Okay, now that strategy works, as I've said, with the second example there, right? 5/6 to 5/8. Why do I say that? What's different from this one, from the example here? That's right, we can only compare them if they've got the same denominators. That's why, that's what they did here, right? So they renamed 2/5 to 4/10 so that 4/10 would have the same denominator as 7/10. Okay, so that's really one of the goals that we want to have. We want those fractions to have the same denominator, right? But what we did in the first example is that we turned them into decimals. Why can't we do that with the second example? If we said that that was a more efficient way or a better way, what's different here this time? Who can convert 5, 6 into decimals? What happens when you convert that to decimals? It becomes a non-stop decimal. That's right. It's a non-terminating decimal. What did you get, Sean? So 5/6, 5 divided by 6 becomes 8.3333. That doesn't work. If I write 0.8333 to 5/8, although 5/8 would be a terminating one, that will not make this a whole number. So when we convert that into decimals, it doesn't work. The strategy we had a while ago doesn't work for this one. Okay, so just keep that in mind. Sometimes we have all these strategies. Those strategies would work for some. It won't work for others. Okay, so this would probably be your last resort as your strategy, for you to rename both of your fractions so that they've got the same denominator. Okay, now this time you're not looking for the highest common factor, but you're looking for the LCM, or the least common multiple. So the multiples of 6 would be 6, 12, 18, 24, etc. With 8, your multiples are 8, 16, then 24 plus 8 would be 32, etc., etc. And what would be our least common multiple? It would have to be 24, right? And that's why it's 24 here, right? So what do you multiply to? So let's write it down here. 5/6. Let's make that smaller. 5/6 to 5/8. We want them to be 24/24, right? What did you multiply to 6 to get 24? 4. So we multiply this by 4, we multiply the top by 4, so therefore we get 20. Yeah, what did we multiply to 8 to get 24? 3. And we multiply the bottom by 3, we'll multiply the top by 3, and therefore we get 15 there. Now, since they've got their denominators the same, then we can simply say that ratio would be 20 to 15, right? But what can you say about 20 to 15? Is it in simplest form? No, therefore we need to simplify it further. That becomes what? We divide both sides by 5, and therefore we get 4 to 3. Okay, so this is now in simplest form. What's different here this time? We would be multiplying each of them by 10, and we get 21 to 35. So divide 21 by 7, you get 3. Divide 35 by 7, you get 5. And therefore, your simplest form would be 3 to 5. Okay, this time, notice that you've got 2 decimal places here, and therefore you don't just multiply it by 10, because if you just multiply it by 10, you're left with 7.5. So you don't multiply it by 10, but instead you multiply it by 100, so that you end up with 75 with a whole number. So if you multiply this bit by 100, you have to multiply the other term by 100 as well. Okay, and therefore you get 140 to 75. And again, you would need to look for the highest common factor, which is 5, and you divide both terms by 5. Okay, so with fractions, it's like multiplying it and then dividing it, all right? Or sometimes it's the other way around, okay? But what you need to do, or your goal would be to make each of the terms a whole number, all right? And each of those numbers would be simplified. There wouldn't be any other factor that you can divide both of the terms. Okay, does that make sense? It's not as easy at first, but when you get your head around it, it becomes easier. So I really encourage everybody to practice. And don't forget, you've got your exit ticket, 3 things. You learned about ratios, 2 interesting things, how ratios are used and how ratios are used, and also 1 question that you still have about this lesson. Okay? Come on, Rocky, let's go.